Now we're going to move on to the next video dealing with quadratic equations, and I am going to actually have one more part on these videos eventually. We're going to also look at a story problem or two here on this. Okay, so let us look at this here. So quadratic equation, we know that the general form of this is ax squared plus bx plus c is equal to 0. So we've talked about factoring, we've talked about completing the square. Now we're going to use the quadratic formula. And the quadratic formula, I'm going to write it down for us, and then we'll talk about where it comes from. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this quantity inside here, the square root, this b squared minus 4ac, has got a special name, and we'll talk about it later on in this video. It's called the discriminant. And it tells us the nature of the solutions. And as I said, we'll learn about that more later on in this video. So before we just dive in and use this, I do like to show you where this quadratic formula comes from. It's not just some random formula that we randomly got to work. We actually just derive it. And the way we derive it is we just go ahead and start with ax squared. Let me switch to black. Ax squared plus bx plus c equals 0. And then what we're going to do is we're not going to put numbers in for a, b, and c, but we're going to solve for x and we're going to complete the square. So first off, what we start with is we're going to divide everything by a. So we're going to divide everything by a, and we'd have a squared plus b over a times x plus c over a equals 0. Now we're going to solve this just like we did the other ones. So we'd have x squared plus b over a equals negative c over a. I forgot my x here, b over ax. Alright, so now we're going to do the complete the square portion. So we're going to look at this middle term here. I'm not going to say b here, I'm just saying this is the middle term because it's that middle term divided by 2 squared. So what am I going to look at? I'm going to look at the quantity b over 2a quantity squared. And I'm going to add that to both sides of the equation. So what do we have here? We're going to have x squared plus b over a x plus b over 2a quantity squared. I'm not going to multiply it out actually on that side. And then this is equal to negative c over a plus b over 2a quantity squared. So the left-hand side is simply going to factor to x plus b over 2a quantity squared. Now I'm going to work on the right-hand side and try and simplify this a little bit. So this is going to be negative c over a plus b squared over 4a squared. So I just squared everything. Now what I'm going to do is I'm going to find a common denominator and combine terms together there. My common denominator is going to be 4a squared. So the left-hand side is still x plus b over 2a quantity squared. And then the right-hand side is going to be negative 4 times a times c, and then this denominator would be 4a squared. And again, all I did was multiply by 4a over 4a plus b squared over 4a squared. Now I'm going to do one other thing before we take square root of both sides. I'm going to rewrite the right-hand side. squared, and we have b squared minus 4ac all over 4a squared. And you can kind of see already this is starting to take shape to part of the quadratic formula. So now I'm going to take square root of both sides. So the left-hand side would be x plus b over 2a, and then this is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. We're actually almost done. X plus b over 2a. Now, notice though this denominator I can do the square root of. The square root of 4 is 2, and the square root of a squared is just a. So we actually have on the right-hand side now plus or minus the square root of b squared minus 4ac all over 2a. Now I'm just going to subtract. I have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then we can simply combine that, because it's the same denominator, and we wind up with our quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now there's a couple reasons I like going over this derivation of the quadratic formula. One, it kind of shows you how we use completing the square. The second reason I like doing it is that formulas aren't just magical formulas that come from somewhere. We can derive them or prove them from definitions and using just computations. Okay, so that's the important thing. Formulas aren't just magical that appear out of nowhere. There's reasons behind those formulas. All right, so let's look at a couple quick examples here. Quadratic formula is pretty straightforward to use. So we're going to use it to solve the following quadratic equations. So I have 2x squared plus 8x plus 3 equals 0. And now I'm going to go ahead and use quadratic formula. And clearly I'm going to just go ahead and identify a is equal to 2, b is equal to 8, and c is equal to 3. So we're going to use quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we do expect you to have the quadratic formula memorized, and one tip on how to help memorize a quadratic formula is just that every time you use it on a problem, write it down. And even do something kind of silly like I do. Every time you write it down, speak it out loud. You might think you look a little weird talking to yourself, but those things will actually kind of naturally help you commit it to memory without having to just stare at the equation for, minutes and minutes and minutes. All right, so let's look here then. All we're going to do is basically, I call it like kind of equation or formula plug and chugging. We're going to just substitute the numbers into the formula. So I have negative b, so I'd have negative 8 plus or minus the square root of b squared, so 8 squared, minus 4 times a, which is 2, times c, which is 3, and this is going to be all over 2 times 2. And now we just have to simplify this. So I have negative 8 plus or minus the square root of 64 minus 24 all over 4, which would be negative 8 plus or minus the square root of 40 all over 4. And I'll take my time on this and do it in a couple steps here. This would be the same thing as negative 8 plus or minus the square root of 4 times 10 over 4, which this would be negative 8 over 4 plus or minus 2 square roots of 10 over 4. And so we can finally simplify this down to negative 2 plus or minus the square root of 10 over 2. Now, some of you may have noticed that this was actually the exact same problem as we did at the end of the previous video. And I did that on purpose because we should get the same answer. Just because there's other ways to do a problem doesn't mean we should get different answers. If they're all mathematically correct, we should get the same answer. And if you look back at your notes or even look at the end of that other video, this is the answer we got for that quadratic equation. So let's look at one more example here. So this is 2x squared minus 5x plus 5 equals 0. So here we have a is equal to 2, b is equal to negative 5, and c is equal to 5. And then I'll go ahead and, I didn't write that 5 out there. I'll go ahead and write my quadratic formula down. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Alright, now again, just like we did in the previous example, it's just plugging numbers in and seeing what we get. So we have x is equal to negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times 5 all over 2 times 2. So this would be, well, negative 5 is positive 5 plus or minus the square root of 25 minus 40 all over 4, which is equal to 5 plus or minus the square root of negative 15 over 4. Now we come into an issue here. The issue is we have a square root of a negative number, and square roots of negative numbers, well, I don't want to say we can't do them. We can do them, and we'll talk about that in a few sections here, in a few videos. They are just what are referred to as complex numbers. But what that means is, since I can't do this square root without getting a complex number, all this means is that there are no real solutions. So all that work and we find out that there are no real solutions. Alright, the last thing I want to cover in this video is talking about the discriminant. So the discriminant again is this quantity b squared minus 4ac. And there's several different things that it tells us. So first off, if b squared minus 4ac is greater than 0, what that tells us is we have two real distinct solutions. So we have two solutions, they're both real numbers, and they're distinct, which means they're different numbers. We don't get two solutions that are the same number. Which actually brings us to the second one. If you have b squared minus 4ac equals 0, this means we have one real, and sometimes they say repeated, solution. And that will come on into play later on in this semester, this concept of a repeated solution. But it's one real solution. And then the third case, which is what we happened in the previous problem, is if you have b squared minus 4ac being less than 0. If b squared minus 4ac is less than 0, we have two non-real solutions, or what we'll learn in a couple videos here, these would be called two complex solutions. Okay, so then let's talk about an example here, and this will be the last example. So this is just going to be determine the nature of the solutions for 2x squared minus x minus 1 equals 0. So since we're determining the nature of the solution, we're not asked to solve it. We just need to know, are they two real solutions, one real solution, two complex solutions. So we're going to use the discriminant. And so the discriminant again is b squared minus 4ac. And so just looking at what we have here, b is negative 1, so I'd have negative 1 squared minus 4 times 2 times negative 1. So negative 1 squared is, of course, positive 1. And then negative 4 times 2, this would be positive 8, or positive 8. And so we get 9. Now the fact that it's 9 isn't really that big of a deal. The issue here is that it's positive. That's the important thing here. So let me scroll back up here. If it's positive, meaning it's greater than 0, that means I have two real distinct solutions. Okay, so in the last video on quadratic equations, we're going to look at just a couple examples of some, we'll call them applications. They're not necessarily applications the way we might think of them, but we'll look at them and do a couple example problems with that.